Hello, everyone. How you doing? Good? There was like one set of thumbs up over there. The rest of you are awake still? A thumbs up! Amazing! I know, right? It's so American. I can't help it. Hello, everyone. So we're going to talk about a very, I think, relevant topic for anyone who's ever built anything in this ecosystem and you start to achieve some success in it. You're eventually going to get to this question. When you are starting off as a smart contract, should you eventually migrate that into a parachain? What are the considerations? What are the drawbacks? What are the pros? And within Polkadot, how do you do that specifically? So first of all, my name is Ben. I work at a small company based in Berlin called Parity Technologies. We do stuff around Polkadot. It's a lot of fun. You may have heard of it, may not have heard of it. If you haven't, come and talk to me after. We can talk all about Parity. And I work in the DevRel team, which basically means we're like extroverted engineers. So we just talk a lot. And that's a bit about me, and let's get right into the subject. So the way that I want to start this conversation is with a foundational premise. If you are in this moment, if you are thinking about, should my Dapp as a smart contract become a parachain, you are probably somewhere around there, which means that you are building something that is gaining traction. You are building something that is gaining users, fulfilling a need case. And why do I say that? Because if you're in that point where you're wondering, should it do this, should it not do this, should it be a parachain, you're probably experiencing growth, quarter over quarter, month over month, new users, new activity, and you're starting to experience the pain of growth as a Dapp, as a smart contract. What is one pain point that you may experience as you're growing as a smart contract? Does anyone know? One pain point. Just one. You're like, I don't know, Ben. That's why I'm sitting in this room. Why don't you talk to me already? So one pain point you may experience is increased pricing and increased costs around your gas fees, for example, right? So as you're growing, you have to start scaling your transactions, more and more transactions, and you're starting to increase more and more costs. That's just one. We're actually going to talk about several others as well. But so you're now in that place, you're building something, you're experiencing that pain point, and you're like, well, maybe I built this, and it's pretty awesome. And if you're in Polkadot, you probably have built this, hopefully, with this cute little guy, which this guy's name is Squink. Squink comes from the Ink language. Ink is the language that allows you, it's a DSL built on top of Rust that allows you to build smart contracts really efficiently, lets you get up and running to ship things quickly, and lets you not worry about all the details around what you actually want to build. It abstracts that away for you and lets you actually just get down to the business of building what you actually want to build. So you've started building something, you've built it with Ink, and you've launched it, and you're starting to experience those pain points. Your Dapp is really, really successful. But perhaps it's just a little too successful. And we've already alluded to what that means. Primarily, it means things like you're starting to experience really high transaction fees, really high gas fees, I should say. You're experiencing other problems we're going to talk about in a minute. And you're really at that point of this dialectical tension between being a smart contract, a Dapp as a smart contract on one hand, and being a Dapp as a fully fledged blockchain, a parachain on the other hand. And that dialectical tension really rests between the two poles of technical complexity and developmental ease. So what I mean by that is when you are a smart contract, right? Your Dapp is a smart contract. Well, a lot of stuff, especially if you wrote it in Ink, is abstracted away for you. You don't have to worry about a lot of the sort of the layers around it, and you can build your Dapp that does something awesome. And you just build on the thing you want to think about. You compile it to a WASM blob, you upload it to the smart contract chain, and you're done. It's out there. It's amazing. But you don't have a lot of customization around those other things. because it's defined for you. It's kind of like if you're a web developer and you picked a framework to build your web app with. That framework has made a lot of opinionated decisions for you. And you may agree with those opinionated decisions, you may not agree with those opinionated decisions, but once you're in that framework, you're kind of locked in. And that's essentially what's happening when you choose to build as a smart contract. But on the other hand, if you go and say, I want to build it as my full independent blockchain, my Dapp is going to be a blockchain, well, then you get to customize everything from end to end. But comes along with that same customization is, of course, increased technical complexity. More things that you as the developer or as the developer team have to worry about. And you have to struggle between those 2 points in that tension. Which one do you want to lean into more in that moment? Do you want more customization, more freedom, or do you want to be able to iterate quickly, get it out, ship it, and start building your users? Now, probably you started more on that side, shipping it out, getting it quickly done. But now you're experiencing the limitations of that customization. And just as that journey can best be illustrated sort of like in the Polkadot ecosystem is building Dapp, you start off in that wide accessibility of Ink. Ink is really just a beautiful entryway to start building something, and then you launch it as a smart contract on a chain, on a smart contract chain, and then you reach into that point where you're starting to need to expand, to create more customization, so you want to refactor that into its own blockchain. So now you've entered the world of Frame. Who's heard of Frame? You've entered the world of Frame, the modular framework, right, that is used with palettes you can use for voting and for other things. And you've started entering the world of Substrate, the SDK to let you start building blockchains. And as you start going down that path, you start encountering increased technical complexity. Make sense so far? We're all together? I see some nodding heads. You're all awake. If not, there are like Red Bulls still, which is awesome. So that's basically where we're at. Now, when your Dapp is a smart contract, we talked about one pain point of being a smart contract when your Dapp is a smart contract, which is the increased gas fees. But there are other ones as well. So for example, when you upload your contract onto someone else's chain, who is defining the state transition logic on that chain? Is it you as the smart contract author, or is it it's the chain, right? It's not your chain. You don't get to define how blocks are produced on that chain. And if you need to have some customization there, do things a little different, not your ability. You're on someone else's chain, right? Things like you're resource limited potentially. It could be scalability issues as you're on somebody else's chain. And of course, as we mentioned already, which I think is a really big one, it's really hard to start predicting costs from the business side of your Dapp when you have unpredictable gas fees, right? So these are some of the problems, some of the limitations that you will encounter as you go and increase your popularity, finding more of a niche, more users when your Dapp is a smart contract. Now, on the other hand, when your Dapp is a parachain, well, as a blockchain, you can define everything, right? You define the state transition logic for your chain because it's your chain. It's the speed of your own runtime because you are the creator, you are the builder of the runtime. It's your own runtime. You have no gas fees because it's your chain. Do you hear a theme happening here? It's your chain. So it's your chain, and therefore it's your chain. And you don't have gas fees, and you can define the state transition logic. You could do all of those things, so you have predictable costs. But that also comes, of course, at the increased technical complexity. So now that we have a sense of what are the limitations, what are the considerations you may be thinking about as you are in that path, or maybe one day we'll get to that path of a popular Dapp that you built out as a smart contract, and now you're like, wait, it should maybe should become its own parachain. But let's actually talk about how you do it within the context of Polkadot. What does that path look like? But before we get there, there might be someone in this room right now, there might be someone watching this later, the recording of it, who has no idea of the words I'm saying, who doesn't even know, wait, Ben, what is a parachain? What are you even talking about? So if you're in this room, you came because you came to Prague Blockchain Week, you're sitting in the back by yourself, not that any of you in the back are in this category, but you're sitting in the back by yourself, you're like, he's saying these words, I don't quite know what they mean. Let's just take a minute to define our definitions, just so we have a shared common language. So when we talk about parachains, we're talking about the context of Polkadot. Those are some very big English words which, are on like college admissions tests in the United States. Those are words that you don't have to know, but we'll break them down together. Essentially, Polkadot is a heterogeneous multi-chain protocol. What does heterogeneous mean? It's a diverse multi-chain protocol, so a bunch of blockchains serving diverse use cases and diverse builds all together. Why are they all together? For interoperability and shared security. What does interoperability mean? Basically means that they can talk to each other and that they can share assets, they can share information, that they have a common layer that can communicate across each other. By the way, what's that common layer called? I'll give you a hint, it's an X. XCMP! The common layer is XCMP, and it is brilliant. You should all learn XCMP. So basically, Polkadot is this heterogeneous, this diverse multi-chain system where they all connect together for shared security and the ability to talk to each other. And it kind of looks like this. You probably, in the room, many of you, maybe most of you, have seen this before, a version of this, that Polkadot sits at the center, and then what is a parachain? Basically an independent blockchain that is leasing a slot on that relay chain. Oftentimes will be built with Substrate, which is that SDK to build blockchains. But does a Polkadot parachain need to be built with Substrate? I see one head. What do you think? Anyone think it has to be built with Substrate? No, you're all brilliant geniuses. No, it does not have to be built with Substrate. You can build your Polkadot parachain in any language that can compile to WebAssembly into WASM. What are some language examples? I personally, you may have noticed my social media handle is Hummus on Rails, because there are two things I love the most in the world besides my family. Hummus, gotta love hummus. And I love Ruby on Rails. I'm a classic Ruby developer for a long time. I would love to see a Ruby-written blockchain on Polkadot. So if any of you here wants to create a Ruby parachain, I will become your biggest fan. I will stake Dot. I will do whatever it takes to help you get that Ruby parachain up and running. Because you can write your parachain in Ruby, in TypeScript, in JavaScript, in Python. But it happens to be that our language of choice in our ecosystem, the tooling, everything is written around Rust, because Rust is awesome for its type safety and its concurrency and its speed, and helps developers build better code overall, although it does have a steeper learning curve. But so that's to say that most parachains, at this point all parachains, are written with Substrate, but it doesn't have to be. So that's essentially the map. Which of course means then the parachains, as we said, are basically just independent blockchains that are renting space, leasing space on Polkadot. Great. Okay, now that we have those definitions in place, how do you go from a Dapp on a smart contract into a parachain? So first thing to say, when we're talking about smart contract to parachain, in the context of this conversation, what we're talking about is ink to Substrate. How do you go from ink to Substrate? Is there an easy golden path that can take you, and you take your code written in ink and you just do a quick little CLI command, and now it's a fully fledged Substrate code base? Does that exist? It does not yet exist. If you want it to exist, I would encourage you to help build this thing, because it would be very, very useful and helpful for many people. But given the fact that it doesn't exist, you actually have a lot of leg up. And you have a head start if you've built your smart contract as an ink contract when you're coming into Substrate. What are some of the head starts? For example, I mentioned that Rust is a great language to develop in because it's got great type safety, great concurrency, it's really fast. It forces you to write, for the most part, pretty good, clean code. But I also mentioned that it has a steep learning curve, right? And as someone who learned Rust in the past year and a half or so, I can attest to its steep learning curve. So if you've taken the time to learn Rust, to build that ink smart contract, you're still in the exact same ecosystem when you're coming to Substrate. All the things you did, all the peculiarities around memory and borrowing and lifetimes and generics and Rust, all those things equally will apply in Substrate when you're coming from ink, which is great. And on top of that, the same primitives are used from ink to Substrate. So once you've gotten used to using the primitives like block number and other ones, you can actually take those and balance the asset primitives. You can take those, that same idea, the same things you built with, the same primitives, and build in Substrate as well. And lastly, the encoding and decoding is all the same. It's used, but they both use Scale, which is an open source library. It finds on Parity's GitHub repository, and they both use Scale. So once you understood sort of the ins and outs of Scale for encoding and decoding, and when you've done that in ink, you could take that same learning you did for ink and apply it to Substrate, which is great. These things actually will help you conceptually as a developer when you're refactoring your smart contract into a parachain. It helps you conceptually and also helps you practically as you're literally building the code, writing that code to refactor from the smart contract into a Dapp. So let's take a quick example. So this is, I showed this earlier, we're going to spend a second on it. This is a fully functioning smart contract in this code example. What does this smart contract do? It does the biggest use case you can imagine. It's the most needed smart contract the world's ever seen. It takes a value and allows you to flip the value. Isn't that amazing? I mean, that's really, like we talk about the mass adoption of Web3, that'll be the panel later. This is what will bring mass adoption of Web3. This is what's really missing out there in the world. But having said that, this is a fully functioning smart contract. And you notice things like the macros above it, like to instantiate the contract with ink contract at the very top, things like the constructor macro and message, and which allows you to create functions that you can invoke, and extrinsics essentially you can invoke and call. So that's all there. That smart contract, now that's a simplified version of course, but that smart contract can be entirely written in Substrate to accomplish the exact same thing. Now, when you write it in Substrate, you're going to have to worry about some other things that you don't have to worry about in ink, because you're now writing not only a smart contract, but you are writing a full blockchain. So this is that code. That is that smart contract in Substrate. So from ink to Substrate. It's a little bit longer, is it not? There's a little bit more lines of code there, just a few. But you're going to notice some similarities. And I really want to highlight the similarities for you, because I think that's what's so important when you are in that space, whether you are the developer or you're working with the developers, to help understand the common space you're operating in, even if the code looks a little different. So for example, we see you get to define the storage. So within ink, you had that ink storage. Here you have palette storage, right? So you're defining the storage just like you define the storage in your ink contract. And you also define what happens when you construct the, when you launch the blockchain, the first Genesis block on the blockchain, which is similar to the constructor in the ink constructor. What is the first value of the smart contract when you instantiate the contract is a similar question and dealt with similarly, although different syntax of course, with the first Genesis block of your chain. And lastly, just like you had ink message, you have palette call, which is where you define the extrinsics, define the functions that you would invoke in your chain. And it's basically the exact same one, which is to take the value, the last line there, take the value and mutate the value. If the value is something of x, make it the opposite of x. So in this case, it's a Boolean, the value is true, make it false. If it's false, make it true. So it is possible. There is not a golden mean path. There is not a CLI tool that you can use to quickly change your code from ink to Substrate, but you are coming to this challenge with tools and with concepts and already kind of cognitively primed to do this journey. You can do this. You can take your Ink smart contract and you really, truly can make it into a substrate parachain. It is really, really possible. Now, in addition to all of that, so we talked about the journey about going from a smart contract to a parachain. This might not be a surprise for many of you. At this point, certainly not. But who in the room has heard of something called, well, it may be called something differently eventually, but parathreads? Parathreads. So about half of you have heard of parathreads, which is great, because when I asked this question a few months ago, the answer was like 3 people in the room. So it seems like it's spreading in knowledge, which is fantastic. What essentially are parathreads? So this may look familiar to some of you. This is sort of that idea of the Polkadot ecosystem with the relay chain occupying that center space, and then you see parachain slots like we talked about. But then amongst this, you also see something called a parathread pool. And parathreads, well, that seems different. What exactly is a parathread in the context of Polkadot and parachains? To understand what a parathread is, you have to understand the problems that it seeks to solve. And parathreads come into this conversation essentially trying to solve 2 problems at once. One is, depending on the market, leasing a slot on Polkadot can be more or less expensive. And depending on your financing and your funding and your ability, that can present a significant hurdle for a new project trying to go from a smart contract into a parachain slot. That's the first problem. The second problem is, depending on your use case, you may not need to have that lease slot available to you 24 hours a day, 7 days a week. Because perhaps your project, your use case, is only producing blocks sporadically, maybe a few times a day, once an hour, whatever the rate is. And when you get a parachain slot, you are getting a fully dedicated portion of block space available to you at all times. And so you're paying for that. You may not need that. So what then is a parathread in this context? It's basically a pay-as-you-go parachain opportunity. So you pay for the blocks you produce. You pay for what you do on the chain as opposed to the dedicated slot, which is an incredible step in this journey. So when we talk about the journey, we talk about going from ink to substrate, going from a smart contract to a parachain, but now we can have an intermediate step between the two. Instead of ink to parachain, instead of ink substrate smart contract to parachain, you can now, as you grow in your utility, as you grow in your use, as the project continues to expand in transactions and blocks and popularity and all those things, you now are presented with an intermediate step between a full-fledged dedicated block space parachain and a smart contract with, in the middle, pay-as-you-go parachain. That's pretty awesome. That's a great, great tool in your builder's toolkit. Now, just to recap and to kind of put it together, we're left with, I think, 3 concrete ideas, a couple concrete ideas. First of all, when we talk about going from a smart contract to a parachain in the context of Polkadot, most often we're talking about going from ink to substrate. And in that case, we have some benefits as developers, as builders, when we do that process. We're using the same Rust language, same primitives, and same tool for encoding and decoding. When we talk about parachains, we're talking about essentially fully sovereign blockchains that are built and controlled end-to-end by the community of that blockchain that connect to Polkadot for interoperability, for the ability to communicate one to another, and for the shared security model of being on the Polkadot relay chain. And lastly, coming soon, which about half of you understood already, is the idea of parathreads as an incredible intermediate step to allow you to continue to build, I would say allow you to continue to build holistically and organically and scale up as you need to, and use the block space offered by Polkadot most efficiently. I hope that made sense. I hope that was a nice journey, and you understand that while we don't have a clear and, I would say, golden path to create immediately a smart contract into a Parachain. There is no smart contract to Parachain CLI tool yet. We do have many things leading us down that road that can help you. This QR code leads you to our live stream schedule that our team and the rest of the Parity team as well, and Web3 Foundation, etc. We do a lot of live streaming every week, every day practically of every week. I would really encourage you to join us. We have roughly week to week around 3,000 to 4,000 people that join us in our live streams on each individual show. It's a fantastic opportunity to engage. If you've never been on a live stream or participated as an audience member in a live stream, it's not frontal. Let's just make this clear. You actually get to talk and engage, ask questions, converse with the host and the guests. You're not just like watching a TV show in your living room. You're actually really engaged in a conversation. So I really encourage you to go to that link or scan that QR code and join us. We're continuing these conversations on Substrate, on Ink, on Polkadot, talking about building all the tools. It's really, even when you're not in the room together here in Prague, enjoying this beautiful rainy weather, I guess, when you're not enjoying the rainy weather of Prague and you're in your own living room, wherever you are in the world, you can connect with us through the live stream. Thank you very much. One minute for questions. I'm very exacting. You had your hand up right away. That either makes me scared or I don't know what else. Okay.
Yeah, scared.
Okay, I'm scared.
Definitely.
I'm ready.
I do have a Parachain for a couple of years now, so I'm going to ask tough questions.
Okay.
First one is to the audience. Does anybody here have a problem of having a popular Dapp that they need to solve how to scale further and get into a Parachain? Anybody? No. I thought so. We don't have that problem yet. Not in Polkadot. So the reasons to go for a Parachain are a little bit different at this point in time. What you're talking about, the reason is something 5 years down the road because Ink is not ready yet even. Anyway, one thing you haven't mentioned is what is the downside, what is the cost in time and money to build and maintain a Parachain. So that's something that should be part of your presentation and discussion, so hopefully you can answer it for the audience.
I really appreciate that question. I also appreciate that oftentimes questions in the audience are opportunities for soapbox comments in addition to questions. You are welcome to present as well. I do think actually Ink is ready for production use. That's my personal opinion and I've seen it. If you differ, that's wonderful, and I would love to see your presentation on that. That's great. But the second question as well of the business costs and the economic costs of running a Parachain, that is actually a different presentation. It's not the topic for this one right now. And I also don't believe we're 5 years away from the problem. I actually think we're much closer to the problem than you think. Even if you said it really definitively, I'd still disagree. Amazing. Thank you very much.